Okay, so today's session is for class 9 student ICSC and maybe other board that as all of you know that Newton's second law, right? So Newton's second law is saying that rate of change of momentum is directly proportional to the the force or the net force applied on an object, right? So, according to Newton's second law, force is equal to mass into acceleration. Now, you are getting question where the force is constant and what is the relation between mass and acceleration. Okay. Now, for constant force, now first let me write down the what is Newton relation. So, force is equal to mass into acceleration. Let's say F is equal net force F is equal to 10 Newton. So your force is constant. Now what will be the graph between mass and acceleration? Now force is constant. So what you have to do? You have to plot a data, right? So graph for drawing graph, as all of you know that starting from class 9, you have to learn this. Let's say this is X and this is Y, or for our case, we are taking its mass and acceleration. So for this case, mass into acceleration is equal to 10. If you are taking mass 1, acceleration will be 10. If you are taking mass 2, acceleration will be 5. If you are taking mass is equal to let's say 4, acceleration will be according to 2.5, like this. If mass is 5, acceleration, 2. If mass is 10, acceleration is 1. So if you see that for a constant force of 10 Newton, when mass is increasing, the acceleration is decreasing. The mass is minimum around 1 kg, acceleration maximum. So mass and acceleration is inverse variable. They are inversely proportional, right? So to draw the graph, you have to understand the relation between mass and acceleration with some data. So your data set is ready. With this data point, you have to draw a graph. Okay. So that means if you forget, whatever you have to deliver at on spot, you can prepare the graph by plotting this data. You will get the graph, right? So this is about the mass and acceleration, the relation. Now let's plot this graph over here. We'll get the details. Okay. Now if we draw here, a force is equal to mass into acceleration. Then what will happen? Let's say mass in the x-axis, acceleration is in the y-axis. What happened when mass, if 1 kilo, 2 kilo, 3 kilo, 4, 5, 10. When mass is 1 kg, acceleration will be 10. So acceleration, let us write 1, 2, 3, 4, 5, like 10. So this is the point, right? This is the point. This point value is 1 comma 10. Next point, mass 2, acceleration 5. Mass is 2, acceleration 5. So this point. So this is the point. Then next is the mass is 4, acceleration 2.5. So this will be the point. Next is mass is 5, acceleration is 2. So this is the point. Okay, like this. Now next is mass is 10. Mass is 10, acceleration 1. This point. So if you join the data, yeah. So this is your graph. So this way you can build the graphical relations for any physical parameters. Just go through like this. I hope this will really help you, okay, to solving different critical problem, right? And one more thing, what I can say that if someone is a relation between mass and 1 by a, then what happens? Mass and 1 by a, it will be a straight line because mass and acceleration they are inverse, but 1 by a and mass is not inverse. Why? Because F is equal to ma. F is equal to ma, or a force is constant, or m is equal to F by a. So if force is constant, m is directly proportional to 1 by a. So this will be like a straight line. Okay, so mass and a is an graph like this. Okay, just go through this, and I hope that this session will be helpful for you. Okay, thank you.